So, review sheet S, numerical methods, question 1. Use a trapezium ball with 5 ordinates to find an approximate value for the area bounded by the curve y equals 3.5 to the x-axis, and the lines x equals 1 and x equals 5. Well, doing numerical methods here, the first thing we've got to work out or be aware of is the strip width. And I always make a bit of a fuss out of working this out at the beginning. So the upper limit is 5, the lower limit is 1. We've got 5 ordinates, and if you think about 5 ordinates, that's 4 strips, because only 2 ordinates create 1 strip at the beginning, and each ordinate creates another strip, so there's 4 strips. So it's 5 minus 1 over 4, which equals 1. And I knew the strip width was 1, but just want to be very clear about that. Second thing, it's all about accuracy when doing numerical methods. So I've got my x values going from 1 to 5 in steps of 1, so 1, 2, 3, 4, 5, that's my 5 ordinates, and the 4 strips, if you like, between them. And then I want my f of x values. Well, to do that I'm going to go to my calculator, and I'm going to bring my calculator in. Let's put that in. Oh, I just want to get that. Right, okay, so I wanted to set it so you can see it in the light. Is that good? Yeah, that's good. Okay, so we're going to work out all the values for my function f of x, which is 3.5 to the x. So I'm going to go menu, and I'm going to choose option 9, which is table mode, or I can go menu and move around on this thing, and I'll get to 9 eventually. Table mode, there it is. Okay, so the function is 3.5 to the power of, use my x button, to the power of x equals, this g of x is just, it does 2 functions at once, so I'm just going to press equals, I don't need g of x. Happens to be set right here, but starting value is 1, end value is 5, that's good, start value, end value, and the step is 1, so it's all good. So I'll put that across. Another little thing is, it's good to mouse across onto the value, so I can see that really clearly on my display, and I'm going to mouse down as I go, so I get these values very, very accurately written in. So where it's exact, I'll just write 3.5, obviously I can write that one exactly. So the next one, if I go down, is 12.25, that's nice and easy, because it's exact. And now I'm going to get 42.875. Now I know the answer is required to 1 decimal place, but it's all about accuracy, so I'm going to keep a good level of accuracy, 150.0625. Why not write them all down, since it's not that many to write down? Okay, maybe not to write them all down here. 525.21875. Do you know what? It's easier just to write them down rather than actually think about what accuracy I actually want. I'll keep it as accurate as the calculator's given it to me. In this case, it's actually exact. Okay, so now it's just about stating that from the formula, from my area of a trapezium rule, the area equals a half h, the strip width, first plus last, so y0 plus yn plus 2 times rest of y's. So that's all I'm going to use. So in this case it's a half times 1, big square brackets, 3.5 plus first plus last, 525.21875 plus 2 times the rest of the values added up, which is 12.25 plus 42.875 plus 150.0625. Close brackets, close my big square brackets. Notice I'm not trying to force loads of digits into a small place. I'm trying to keep it so I can see the accuracy. Oh, another little thing is when you do the tables, I think it's better to lay it out vertically so you can write. You've got room for success. You can write out a good number of digits. Whereas if you do a sort of table horizontally, you can sort of run out of space, and you can sort of find yourself having to squeeze a lot of digits into a small space. So my area equals. So I'll put this into the calculator. So I'll have to go back menu to 1, and then I'll just type fraction button 1 over 2. Open big square brackets, or open my big brackets. 3.5 plus 525.21875 plus, I'll have to put this paper out of the way so I can't see the values, plus 2 open brackets 12.25 plus 42.875 plus 150.0625, close brackets, equals S to D, so 469.54, and so 469.5468. I don't do any round until I get right to the end, and I want it to one decimal place, so 469.51 decimal place. Now, they asked us to, it was a show that question, so we can just check that we've got the answer they asked to show that, which was correct, 469.5. If it wasn't, I would definitely put this in as an integral on the calculator and check it, so I could just just show you what I mean. So I could do this exactly and say 3.5 to the power of x between the limits of 1 and 5 equals, and oh gosh, I didn't mean to do that, just go back, equals. Now the nice thing about doing this is much more accurate than mine, because it's essentially a numerical method with really tiny strip widths. So and we get 416, and it tells us that this answer here is an overestimate. This 469.5 is an overestimate, so that might be useful if I need that for the next part.